Welcome everyone. So in this session we are going to talk about Android camera architecture. So the basic agenda to understand the Android camera architecture is because we are working for camera sensor development and we are working mostly on the kernel side, but we should have an overall idea about complete Android camera architecture so that we will be having a better understanding of the code flow and we will be able to optimize the code in future if there is any requirement to optimize the code. So the thing is, if we have complete understanding of the architecture, then only we will be having a good understanding of the code as well, and we can give new suggestions and we can optimize the current architecture and we can avoid the limitation of current architecture by giving the new solutions. So now you can see this. This is the Android high level architecture. We are not going to individual module or individual layer in detail. It's just to give you a high level overview of Android camera architecture. So all like on the top layer of Android, all the applications runs. So this is the application layer. You can see this is SMS, browser, cameras, alarm, calculator, album, clocks. So basically on top layer of Android, we have all the application running. So whatever the application we can see in our phone, like we have WhatsApp, like we have SMS application, we have browser, and so many applications. So all these applications which interact with the user, they are basically exist or they are basically lies on top of Android camera architectures. And after that, we have application framework. Application framework basically provide an environment for running all these applications. Okay, and you might aware about the all the Android application written in Java language by using the Android framework. So Android framework basically provides you the environment where basically all your application which you have developed that can run. So for our part, like for camera, definitely when we are using camera in our Android phone, so we have camera applications there. Okay, so all these camera application comes on the top layer of Android architecture. Okay, and then after application framework we have libraries. So libraries basically provides the SDK support, or we can say the API support to the application framework and the other submodules running in the Android. So like we have Surface Manager, we have Media Framework which will be controlling all the media related stuff. We have WebKit will be which will be dealing with all the web related stuff. We have OpenGL, streamers and all. So we have libc. So all these libraries basically provide support for development of the applications or the application submodules which we have in the Android top layer. And then we have Android runtime which have the Dalvik virtual machines and the core library. So this is basically Android runtime basically provides us the library, or we can say the environment for running this Android operating system. Okay. So now after all this application or user stuff, we enter into the Linux kernel. So you might aware about Android architecture is based on Linux kernel. So what does it mean? It means like maybe all the applications are, when we say operating system. So operating system basically built up of two things. One is user space and the kernel space. I will talk about in the Linux terms. So all the application part, or basically all the user space parts, okay, that need to be interacted with the device or core, or we can say the CPU of your system or your mobile or your any embedded device. So to have an interaction of all these user space applications and other stuff, with the hardware, we need some interface, and to manage all these things, we need some resource. So Linux kernel plays that important role. Or in a nutshell, we can say Linux kernel is kind of most important part of our operating system, Android operating system. So Linux kernel, so Android architecture is based on Linux kernel. So on the lower layer, we are using the Linux kernel for interaction or managing our hardware, or basically Linux kernel, we can say the heart of an operating system for Android. Okay. So Linux kernel has all the drivers, display drivers, camera driver, Bluetooth driver, shared memory driver, power management stuff, Wi-Fi driver, keypad driver, other driver. So Linux kernel will have all the driver which will be supporting the application running in the user space. So now let's say you are using camera application. So for that you will be having a camera driver in the Linux kernel which will be actually interacting with the camera sensor and other camera related devices. In the same way you are using Wi-Fi in your phone. So for Wi-Fi also in the Linux kernel you have Wi-Fi driver. So that Wi-Fi driver basically interact with the your network chips and other network related stuff present in the system. Then you have display driver. So whatever you are able to see on the display of your embedded device or your phone, so that display has to be supported by some display driver. So that display driver present in the Linux kernel. Okay, so let's move ahead. So one layer which we didn't show you in the first slide because we want to discuss more about that, that is hardware abstraction layer. So hardware abstraction layer is basically a layer which abstract the complexity of the hardware. What is the meaning of abstracting the complexity of the hardware? It's like, let's say an Android application developer writing an application for the camera sensor or for the camera or for the display or for any of the module. So because this training is based on camera sensor, so we will be talking about camera related stuff more. So now let's say an Android camera application developer wants to write a camera applications, and you know, like we have lakhs of application available in the Android Google Store. Okay, so one thing is like we will one option is like we will give the full complexity of hardware to the application. We will say Android application developer, you have to know in and out of the device for which you are developing the application. You have to understand the schematic, you have to understand the spec, then you have to write a driver for that, and then you have to write application for that. So don't you think that will be a difficult task? And also all these layers, all these user space layers are totally independent upon the hardware. Okay, so what does it means? It means these applications can be run on multiple platform or the hardwares. Let's say you are using WhatsApp. So WhatsApp can be run in different devices. Your phone can be based on Apple operating system, or we can say the Apple hardware, or Nokia might be using some, or Samsung might be using some Qualcomm hardwares. And even the Qualcomm hardware, they are coming up with a different chipset. But your WhatsApp application can run on all of these hardware. So how this is possible? This is possible because our applications, what an application developer is developing, that's all are hardware independent. Okay, so whatever the stuff till this layer, this library, these all stuff are hardware independent. So now we should we need somebody who will be converting our request that is coming from the hardware independent application for the respective hardware which is underlying in the devices. So it means WhatsApp application will generate some request for, let's say let's say for the camera. If you are opening a camera from the WhatsApp application, or simply if you are opening a camera from the camera applications, so your camera application will generate a generic call because it's a hardware independent. But on the lower layer, you might have Qualcomm based hardware, you might have Samsung based chipset, or you might have XYZ company based chipset. So you need somebody to convert that hardware independent call, to convert that call into the call specific to the hardware present in your embedded device. So hardware abstraction layer do that thing for you. So you will call open, read, write, simple calls from the user space, but your hardware section layer will convert all your generic call to the hardware specific calls. So for each of the devices, you will be having hardware section layer module. So let's say for camera, we have camera hardware abstraction module. For audio, we have audio abstraction hardware abstraction module. For radio, Wi-Fi, GPS. For every stuff, we will be having an hardware abstraction layer. So I hope now you are clear about hardware abstractions layer and what is the use of that. So now this slide is more about camera subsystem. So camera subsystem, as we talked about, like we have application on top of Android architecture, and then we have Android framework, application framework, and then we have camera service layer. So basically, our camera application behaves like a client because it needs information from the underlying hardware, or it needs the frame which is captured by the camera sensor. So this application will create an client object, and that client object will be interacting with the camera service layer. Camera service layer basically will behave like a server to the request which is coming from the camera application. And till this part, this is hardware independent part, as I mentioned in the previous slide. So this is hardware independent part. So if you are working on these layer, you don't need to worry about the hardware present in the system because you are writing a generic code which will be deploying on different hardwares. And then you have camera hall implementation, which is basically the hardware dependent, and hall also divided into two parts that we'll be covering in the next slide. Then we have camera device driver, and when I say camera device driver, it means camera sensor driver, which is present in the Linux kernel. And then on the lower layer you have camera hardware. And note one thing, when I say camera hardware, it doesn't mean it has only camera sensor, because having only camera sensor will not do all your job, because camera sensor will only capture the frames. But how that frames will be optimized, how the quality of that frames will be optimized, and there are other stuff we have, like we have ISP for controlling the quality of the frames captured by your camera sensor. We have EEPROM, we have flash. So all these stuff build a complete camera, but we will be focusing on the camera sensor module. So now this is kind of a process view, like how exactly the process looks like in an Android architecture. So as we discussed, like these all are the application running. So you might have different camera applications, front camera application, back camera application, and different camera applications. Or maybe WhatsApp also using your camera, and other application also, scanner also using your camera. So these application needs a service from the camera service. So as I mentioned earlier, camera service plays a role like a camera server present in the system, which will be basically satisfying the request that is coming from the application. And then you have hardware object. You have basically the for the front camera you will having a front facing camera hardware object. For the back camera you will be having a back camera hardware object. Then by using the system call, actually generally this is not a system call, this is like a vForall2 framework we use for interacting with the camera driver. So basically our HAL layer use vForall2 framework to have an interaction with the kernel driver. We'll be discussing more about this in the coming presentations. And we have surface flanger. So whatever the data our camera sensor is capturing, so our HAL that pass the data to the surface flanger. So surface flanger basically a module which will be taking care of composing your data for the display. So whatever camera sensor is capturing, you see that data on the display, right, as a preview. So Surface Flanger interact do that interaction with the hardware composer for composing your frames to the display. Okay. So this is kind of application flow. So on top of layer we have application code, then we have all the application running in the Java. You know we have JNI. JNI basically Java native interface because all your applications are written in Java. So you need somebody which converts your Java code to the C++ code because our mostly the HAL stuff or camera service layer are written in the C++. For that we use Java native interface. And then we have, as I mentioned, like we have camera service. So basically this lib camera service.s. So this is a shared library which is plays a role of camera service. Then we have our camera HAL implementation. Okay, so this is like where actually the code of these multiple modules present in the Android architecture. So you can go through that if you have an interest. But for our training part, we are not touching upon these modules actually because our training is mostly focused upon the lower layer of Android architecture, that is the camera sensor driver. Yeah, so that was like upper camera stack, and now we have a lower camera stack here. So basically we have camera hardware section layer. So basically HAL is also divided into two part. One is vendor specific HAL, another one is the Google HAL. Because Android is launched by the Google, so Google gives you a native HAL. So native HAL means it will have till that native HAL all the calls will be generic. And like as I mentioned, in each of the embedded device we will be having a different chipset, maybe Qualcomm based chipset, Samsung based chipset, or X and Y company based chipset. And as I mentioned, HAL is dependent upon the hardware, and it abstract the complexity of the hardware, right? So a company which is developing a chipset, they should have their own abstraction layer which can abstract the complexity of their own chipset or the hardware present in the system. So they develop their own HAL. That HAL is called vendor specific HAL. So till Google Camera HAL, you have all the native interface, means generic interface. It's a hardware independent part. But from the vendor specific HAL, basically you will be actually interacting with the hardware. So this HAL will be dependent upon the hardware. Okay. So all your calls which are coming from the upper stack, it will come to the Google native HAL, and Google native HAL will pass that request to the vendor specific HAL. So vendor specific HAL basically will convert your request to the hardware specific format. Okay. Then we have camera driver in the kernel. Then in the kernel, after kernel, we have image sensor, sensor processor, and the other hardware present in the system. And this is surface flanger that we have just discussed in the previous slide. So this part you can ignore. So that was all about we have Android camera architecture. Thank you. Thanks for listening.